Hey everyone. Today we're going to be talking about IPFS Operator and how it simplifies your Kubernetes experience. So my name is Oleg Silkin. I work at Red Hat on a platforms team in emerging technologies. So in this talk, you will learn about how to use Kubernetes. You'll learn about how IPFS Cluster uses Kubernetes. And more importantly, you're going to walk away knowing how you can make Kubernetes work for you instead of against you. So a brief background, this is all about containerization. If you don't know what containers is, I have a neat graphic. So this is the world before containers, and it was not good. We're not going to get into that, but it was not good. So what containers are is it's virtualized software, and basically when you take some package or some binary, you package it with the software that it needs, and then you basically compile it into a container image, and then these go out, and then people just download them from anywhere and are then able to run that software without needing to actually have the dependencies on their system. So it's a really neat ecosystem. For example, if we have the Kubo binary, we can take that, Dockerize it, and that is essentially what you run when you pull from docker.io/IPFS/Kubo latest. And it lives in its own sphere, basically. So we can pass it environment variables like IPFS swarm key. You can set and expose API ports, like it exposes the API port, the swarm port on 4001, and you can mount different volumes and be able to actually plug storage in and out. It's really neat. So one of the main reasons why Docker is so great is that you could just use it at the command line. So if you want to run go IPFS or Kubo today, you can do docker run IPFS go IPFS. Well, today it's Kubo. And it'll just run. It starts the entire binary without worrying about how your system is configured. You could have the messiest system in the world, and this will still run, provided you have Docker installed, of course. So they're really helpful when you have one container. You can set the environment variables as you want. If you have two containers, yeah, they're really helpful. Three, again, we can just keep adding them, but things start to get shaky. So they have their limitations that as you scale them up, because you're just running commands, if you want to make adjustments to it, that's going to cost you a bit of time. Everything has to be done manually, and existing solutions like Docker Swarm are just not that great to use because you need more fine-grained orchestration. You need resources to be available at time of launching. So if you wanted to do something like you want to take a subset of your containers and you wanted to apply a label to them, and then based off that label, you want to apply some IPFS profile, well, you could do that with the Docker CLI, but it's just going to take more bash scripting and a lot of work on your end. And we don't want that. We want you to focus on the code so you can just do your job. So they start to become unproductive as you get more and more containers. At this point, this is just crazy. And then this is ridiculous. This is container overload. We don't want this. This is bad. So here's a quiz. Can anyone tell me what this does? No? No. Can anyone tell me what this does? I'm not seeing any hands. So at some point when you're using containers, your workflow of trying to adjust some API port is going to start looking like this. You don't want to be doing this. You want to be writing code. So the solution is to use actually Kubernetes. It might seem counterintuitive because everyone talks about how it's so hard, but there are a lot of things you can do to make Kubernetes actually work for you. And we're going to show you how to do that. So to first start out, we have to say, what is Kubernetes? It's a container orchestration platform, and what that means is, at its core, it allows you to define how you orchestrate all your different containers. And it does this through a process called eventual consistency, where you define what you want, and it eventually gets to that point. And if there's a problem, it tries to self-heal or basically die doing so. It's made up of a few nodes. There's the control plane and there's worker nodes. The control plane it's like the Futurama brain. Oh, I think I deleted it. We don't need to get into that, but basically it stores the state and then it tries to get everything to that state or to your desired state, and to interact, you just contact its API. It's very self-explanatory, at least when you start working with it, and it makes your life a lot easier. So when we talk about atomicity, it's commonly known that there's the four major elements of nature. We have wind, fire, water, and earth. Well, in software, we have the same thing. We have the four elements of software engineering. We have your application layer, we have your storage layer, your networking layer, and your configuration layer. And most of the time, these are the four main things that you're going to be working with when you're building those precious apps. So in Kubernetes, there are atomic resources for these things. There are other resources beyond this, but they're usually just an extension of these four that do more specific things. Your first one is the pod. That's going to be your application layer. That's going to actually run the code. Then you have the service, and then we have persistent volume claims, which is storage, and then you have the configuration layer. So pods, these are basically like apartments. They provide a common space for containers to exist, and people within their apartments, they do their things. They don't know about the people in the other apartments, but they still share the same water, they still share the same electricity, and pods provide this type of infrastructure. And that's going to be where your application runs. Then you have the service. This is like when you have a telephone operator. They connect different services together and provide a way for them to be accessed. So this is your networking layer. There's different types. There's cluster IP, there's node port, load balancer. We're not going to get into this today, but they exist. There's the storage layer, your persistent volumes. These simply claim pieces of storage. There's different modes you can use, a lot of different things that you can do with these. And then you have your configuration layer, config map secrets, whatever. This is where you actually store your passwords, your scripts, things that your application will need in order to run, but it's not exactly storage in the same sense of generating application data. So now that we've gotten all those out of the way, I'm going to show you how to basically put together a Kubo deployment in Kubernetes. All right, so we're going to go to our handy-dandy VS Code. And the very first thing that we're going to need to do is create a pod. So this is just a VS Code extension. It generates the base boilerplate. It's not very complicated, but we're just going to name this IPFS. And we're going to apply the IPFS label. And down here is where we actually specify which container we're pulling. Here we're going to do the docker.io/IPFS/Kubo latest image. And then for our resource usage, this is we can set limits. This is a default one, but it'll work fine. And then we can expose ports. We're going to keep it simple today. We're just going to do the swarm on 4001. So we expose that. And now we can apply this directly in our cluster. But this is not going to be accessible from the outside world. So what we have to do is we have to create a service to actually access it. So we'll do that. We'll create this separator, and we'll say create a service. And again, I'm going to do that boilerplate because it's helpful. And this is going to be called IPFS service. And then the selector, we're going to do name IPFS. And then here, we're going to expose port 4001. And what this is going to do is it's going to look for the pods with the name IPFS, and it's going to expose their port 4001 to port 4001 in the entire cluster. So in order to, we don't need to do anything else to actually use that. It's just automatically going to do that. The next thing that we'll need is storage. So the way that we do this is we first want to create a PVC. So we'll do that. We'll say persistent volume claim. This is just going to be called IPFS data. And then we're going to like say, I don't know, how much storage do we want? Somebody shout a number out. 5 gigs? 5 bibs? Okay. 5 BI. I don't think that's going to work, but we're going to keep that. And then what we do in order to actually use that storage is we go into our spec and we simply say volumes, and we specify the volume that we want to, or we give it a name. So this is going to be called IPFS storage. And the name here is important because this is actually what the container is going to use as a reference. It's like a variable, basically. And then we're going to specify that we want to pull a persistent volume claim, and the claim name is going to be IPFS data. And then to use this in our container, all we need to do is we go to volumes, volume mounts, I think. And this is just going to be another list. So we need to reference the name. So this is going to be the claim name. This is going to be, what did we call it? IPFS storage. And then we need to tell it where to mount. So this is falling. I know it's, I think that should be good. Okay, so we set the mount path to be /data/IPFS, and now our container is going to be mounting this PVC at that path. And the last thing we'll need to do is actually set, so I want this to be private, so we'll pull in an environment variable, and I'll show that. All we need to do is we go to our container, we specify the envs. Is it env or envs? It's env. And then the name, this is going to be what the container sees. We're going to call it IPFS swarm key. And we'll say, well, we want the value to be from, and we'll tell it where we want it from. I want it from a secret. So we'll say secret key ref. And what this is saying is, go find a secret, and I don't know why key is the first thing it presents, but it wants the name. So the name of our secret, we're going to create this in a second. We'll call it IPFS secret. And then the key is going to be called swarm key. And then we will yank that, and we will create a secret with that value. So we'll say secret IPFS secret, and then, oh wait, yeah. And then the password, this is going to be base 64 encoded. I'm just going to say dead beef here, because that's that. Is that base? No, that's not base 64. I have this value that I made earlier, so I'm going to cheat a bit. And there we go. That is going to be a full IPFS deployment. And if we wanted to actually go and make that, what we can do is we can go to our terminal. We can do apply F, IPFS YAML. Looks like we got an error. V1, blah, blah, blah. Oh, it's complaining about that 5 bibs. So we can just set this to gigs. And if we apply that, it creates everything, and then we can see it in our cluster. And here it's going to be container creating, and now it's actually running. So that's great. So you just watched me put together a bare IPFS deployment, right? How do you all feel about it? Is it easy or was it hard? Okay, well now let me show you what we do for IPFS Cluster, because this is going to be really simple. So first you want to create your relay circuit identity, right? Then you want to create your relay circuit config. And then you want to create your relay circuit. And of course, we need another service to expose it. Then we actually need an IPFS config. Then we need our IPFS secret keys. Then we can't forget storage. We need that. And of course, the IPFS cluster, that needs storage too. And then of course, we need to deploy IPFS. And then of course, we need a way to access it. So that's simple, right? Everyone find that easy? You guys are all Kubernetes masters now. You can go and do that tomorrow, right? Yeah, I didn't think so either, because I certainly have to spend a lot of time Googling this stuff, and I don't want to be doing that, and I don't want anyone else to think that that's how you should be using Kubernetes. So let me show you how we actually do Kubernetes. So the main problem is that it's hard. It's hard to maintain, it's hard to debug, and it's hard to maintain your sanity. And when I say it's hard to maintain it, I mean, if you do the first method that I showed you, and you do that for everything, that's going to get tedious. Just in general, if you're running a complex environment, it's going to be complex. There's going to be a lot of moving pieces, and there's going to be a lot of repetitive work that you're doing back and forth to just get the thing working, and you're going to be wasting a lot of time. You're not going to be happy. You're going to resent your job. You're going to resent what you're doing. And you're going to be doing too much work for too little gain. So our solution is operators. Now, operators are great because they operate everything for you. So they expose very simple interfaces for these very complex things that I just showed you, and they operate on your behalf, and they either try and succeed or they fail and they tell you why, and they give a good reason for it, provided that the reason is easy to access. Asterisks. Most of the time, they're very easy to use. So our YAMLs before operators look like this, right? That's what I just showed you. After that, they look like this. This is what you want to be using. So to do IPFS cluster in Kubernetes, first you want to install this thing called Operator Lifecycle Manager. And this is kind of like on your phone, you have the App Store, and you can just simply press install on an app, and it installs on your phone. So in Kubernetes, we have the same thing through OLM. Then you actually go and install the IPFS operator, and you may wonder how I got this link, right? Because this is not easy to guess. Well, there's this handy-dandy website called Operator Hub, and this is essentially your app store for your Kubernetes operators. All of your glorious things that you want to be using, all of your finest software, your Grafana dashboards, your Apache Kafka, your everything, you can find here. And if you can't find it because you have something custom, you can create them. They're pretty easy to make. And in order to use IPFS cluster in Kubernetes, you simply search for IPFS, you click on that button, you click that glorious blue install button, and it tells you the 3 steps right there for you to install. It's that easy. And then finally, when you actually go and create it, all you need to do is just install that thing or run it. And it might be a bit small, so I'm going to show you how it looks. And we can go through each of the options step by step, because it's really quite simple. So right at the top, we have the kind of IPFS. This has been changed to be kind IPFS cluster. It doesn't really matter. You give it your name. You name your cluster. You tell it how much IPFS storage it should be using. You tell it how much cluster storage it should be using. You tell it how many replicas you want. You tell it how much circuit relays you want. You tell it which clusters to follow, if any. All of these options are just right here in one convenient file. And then you just go and launch that, and I'll show you what that does. Oh, It's a old CR. So we have to modify that. So this is no longer IPFS, it's now IPFS Cluster. There we go, we just created that right there. And then if we do kubectl get all, we'll see all of our resources just right there for us. And we didn't have to do anything. We just deployed a very simple file. It was that easy. So yeah, using Kubernetes is literally this easy. If someone is telling you that it's complex, that it's a lot of work, they've never done this. They don't know about this. Show them this. Show them that this is how you use Kubernetes. If you want to start using operators in Kube today, you can go to operatorhub.io. You can create your own if one doesn't exist through Operator SDK. And then, of course, we have our glorious IPFS operator, which you can download, and I recommend you download it through operatorhub.io. And then, of course, we have our source. So if anyone's interested in furthering this project, in helping us get an even better operator, go to that link, contribute. We would love your help. So I really do hope that people walk away knowing that Kubernetes is just this easy, because that means I don't have to give this talk again. If I don't give this talk again, then I'll have succeeded.